Hi, grade 11. So today we're going to be doing lesson 5.6 and 5.7, which cover the sine law and the cosine law. I combined these two together just because you did learn this in grade 10, so it's just more of a review with a couple extra new things. So there's no handout for this, but you'll just have to take notes on a sheet of paper. So first we'll cover the sine law. So the sine law states for any triangle ABC, the ratios of each side to the sine of its opposite side opposite angle are equal. So if I have this triangle A, B, C, and then the side lengths are opposite, so small a is opposite angle A, small b is opposite angle B, and small c is opposite angle C. These are, by the way, for non-right triangles. It'll also work for right triangles, but you could use the primary trig ratios for that. So this works for non-right triangles, and the sine law is A over sine A equals B over sine B equals C over sine C, or you can flip them and have the sine on the top. Sine A over A equals sine B over B equals sine C over C. All right? So this is useful when you know either two sides and one angle, and that angle is opposite a given side. So that's side-side angle. Or when you know two angles and any side. And that's angle side or angle side angle. All right? However, there is an ambiguous case to be aware of. So, when you're given a side-side angle triangle, there can be 0, 1, or 2 solutions depending on the size of the angle and the lengths of the given sides. So, if angle A is acute, so that means less than 90 degrees, there are 4 options. So the first option is when A is smaller than H, which is the height, and then no triangle, sorry, that should be triangle, not A, no triangle exists. So if I have angle A and then side A, but side A is shorter than the height, and this is side B, then there can't be a triangle because this one has no one to connect to, right? The next case would be if A was the same as the height, then that would be a right triangle. So if A was actually just the height, it's the opposite angle, but it's also the height, that makes that a right triangle. The third case is if A is greater than B, then one triangle exists. So we have angle A, and then we have side A, which is longer than B, then that's our triangle, right? And the fourth case is if A is greater than H, but less than B. Then there can be two triangles. Or just exist. Two triangles exist. So I could have angle A here. Sorry. That's angle A. This is side B. Side A is longer than the height. And that can be one triangle. Or side A could be longer here and come down at an angle that way. And that could also be side A. So those are my options. There's two triangles that could exist. If A is obtuse, angle A is obtuse, so that means greater than 90. Then there's two cases. So the first case is if A is smaller than B or A is equal to B, then no triangle will exist. So this is an obtuse angle, so it opens like that. That's angle A, this is B. If A is smaller than B, then it can't reach the end here, so there will be no triangle. And the other option is if A is greater than B, then there will be one triangle. And that's just the regular, so that's greater, this is B, and A is longer than B, so that one triangle exists. All right, so these are just cases you need to be aware of. They're also in your textbook on page 317. So if you need to look back and just be reminded, because I don't expect you to memorize these, then that's in your textbook. All right, so let's do some examples of how to use this. So example 1. I'm giving you this triangle, and this is triangle A, B, C, where angle B is 60 degrees, angle C is 30 degrees, and I give you this side is 6 and this side is 12. And we need to find angle A, which we'll call theta, and we need to find side length B, which is missing. So this is a 6 and that's a B. All right, so first I can find angle theta because I know that the angles in a triangle add up to 180, right? So that's easy. So theta equals 180 minus 60 minus 30, which is 90. So I didn't draw this correctly, but if I was just given this information, I wouldn't know how to draw it necessarily. So theta equals 90. Now, side B, I can find using the sine law. So I would have side B over sine B equals, and then I can use A or C. I'm going to use C in this case. So side C is 6 and sine 30. I'll put in angle B is 60, so that would be sine 60. And I can solve for B. So in order to do that, I can cross multiply and divide. So B equals sine 60 times 6. So I'd write that 6 sine 60, and then divide by sine 30. And you can just punch that into your calculator. Altogether, 6 sine 60 divided by sine 30, and that equals approximately 10.4. So side B equals approximately 10.4. Now, number 2. You're given the information that you have a triangle, angle A is 20 degrees, side A is 60, and B is 10. Now, I need to draw this triangle and find all the possible solutions. So if I look at my possibilities, and I notice that A is smaller than B. So looking back, A is smaller than B, and angle A was 20, so that's acute. So if A is acute, yes, it's acute, and A is less than B, so that's here, that means there's two possible solutions. Okay, so I'm just going to write that. Two possible solutions. Now, I'm just going to draw my triangle. So if I have angle A, which is 20, that's pretty small, 20, and then side A is 6, and B is 10. All right, so let's find angle B to start, and then we can find angle C after that. So angle B would be sine B over B, which is 10, equals sine A, which is 20, over A, which is 6. So cross multiply and divide. 10 times sine 20 divided by 6. So B equals sine inverse of 10 sine 20 divided by 6. It's always best to leave this in this form and not calculate it because you'll end up rounding and then it'll be less accurate. So punch that into your calculator and you will get 34.8 degrees. So angle B is approximately 34.8 degrees. And then I could calculate angle C by doing 180 minus 20 minus 34.8, and that is 125.2. Right, so that's option 1. Option 2 is if I had my angle 20, and this was A, this was B, this was C, side B was 10, and side A came down like that and was 6. Now, if I put these numbers in, I would get the same answer, but I know that there's 2 possible solutions. So I have to think about what we learned with the CAST system, and that is that I know sine is positive in quadrant 1 and 2. Now that I know that there's going to be 2 possible solutions. So my first solution was 34.8, which would occur in quadrant 1. Now using the related acute angle, if I draw that same angle in quadrant 2, 34.8, I can calculate this principal angle, and that will be the other solution. So that would be 180, which happens here, minus 34.8 would give me the solution. So 180 minus 34.8 equals 145.2. Using that as B, I can calculate C equals 180 minus 145.2 minus angle A, which is 20, and that equals 14.8. Right? And one more example, number 3. If I'm given the information, angle A is 40 degrees, A equals 4, and B equals 10. And I need to find all possible solutions. So A is less than B and it's acute. So again, there might be 2 solutions. 2 possible solutions. So if it helps you just to draw a little sketch, A is 4 and B is 10. Now I'm going to try to calculate angle B. So sine B over B, which is 10, equals sine A, which is sine 40, over A, which is 4. Cross multiply and divide. 10 sine 40 divided by 4. And then sine inverse to calculate the angle. Punch that into your calculator and you get error. So this means that there's no possible solution for this one. All right, so that's undefined. There's no solution. This triangle is not possible. And that's just the answer. So now we'll move on to the cosine law. And the cosine law states, the cosine law can be used if you know side angle side, which is 2 sides with the angle between them, or if you know side, side, side. All 3 sides. And using triangle ABC again, the cosine law is A squared equals B squared plus C squared minus 2BC cos A. Or it can be rearranged to be b squared equals a squared plus c squared minus 2ac cos b, or c squared equals a squared plus b squared minus 2ab cos c. All right, so let's do an example using this. So I'm just gonna get a picture here for a second. So this is just a problem from the textbook. Mitchell wants his 8.0 meter wide house to be heated with a solar hot water system. The tubes form an array that is 5.1 meters long. In order for the system to be effective, the array must be installed on the south side of the roof, and the roof needs to be inclined by 60 degrees. If the north side of the roof is inclined more than 40 degrees, the roof will be too steep for Mitchell to install the system himself. Will Mitchell be able to install the system by himself? So we need to find if the north side will be inclined more than 40 degrees. All right, so let me just grab the sketch of this. All right, so here's a little sketch of this. This is from your textbook on page 323, if you want to read the problem again. So we need to find angle C here. Which we're calling theta. But we don't have enough information to find angle C. We have side angle side, so we can use the cosine law to find side A, to find side B, and then we'll be able to use the cosine law to find angle C. So let's find side B. So B squared equals A squared plus C squared minus 2ac cos b. Now we'll plug in the information from the diagram. So b squared we don't know. A squared is 8.0. C squared is 5.1 minus 2 times 8.0 times 5.1 times cos, and angle B is 60 degrees. Now, 8 squared is 64. 5.1 squared is 26.01. And then 2 times 8 times 5.1 times cos 60 is 40.8. So do this addition and subtraction, and b squared equals 49.21. Take the square root of both sides, and b equals approximately 7.01 meters. Now, I know side B is 7.01. Now I can find angle C because I have enough information for that. So I can do sine B over B equals sine C over C. So angle B is 60 degrees, so sine 60 over 7.01 equals sine C, which is theta, over side C, which is 5.1. So sine theta equals, we'll cross multiply and divide. So 5.1 sine 60 divided by 7.01. And then we'll do the inverse of sine. I'll just go down here. And that equals approximately 39 degrees. So Mitchell's roof, we'll write a therefore statement. Therefore, his roof is inclined by 39 degrees on the north side. So he will be able to install it himself because it's less than 40. All right, and that's it for the lesson. So let me know if you have any questions, and I'll talk to you soon.